Hi there. For today's experiment, I'm going to be measuring a 100-watt line ceiling speaker. 100-watt line ceiling speakers and other loudspeakers allow us to run multiple loudspeakers on a single amp channel using step-up and step-down transformers. This ceiling loudspeaker has got a tapping setting for the transformer to give us different impedances at each tap, resulting in a different output wattage and then hopefully in a different level output as well. That's what I'm going to be measuring today. So I have a 100-watt line amplifier. I'm set up in my garage. I'm going to be measuring at 3 positions for each of the tapping settings at a 0.5 meter, 1 meter, and 2 meter. Hopefully I'll be able to see some inverse square law results with half space and double space. And then at the different tappings, the 5 tap, the 10 tap, the 20 tap, and the 40-watt tap, we'll also hopefully see some level variances. My microphone is calibrated with amplitude, and the amplifier is going to stay at the same volume output for each tap and each measurement. Okay, let's get measuring. Okay, so we have some information here. Okay, so now I've gone and measured at each tap 5 watt, 10 watt, 20 watt, and 40 watt at a 0.5 meter, 1 meter, and 2 meter. Okay, let's start with one distance away. And just, I'm not really looking for frequency content. I'm more looking for SPL content. So I know the speaker is not completely flat. It is a seating speaker made for public address background music. So I'm just looking for the frequency or the level information as opposed to the frequency information. Okay, so go and just hide all of these traces and let's have a look. So let's start with 5 watt, 1 meter. There we go. And then let's go to 10 watt, 20 watt, and 40 watt, 1 meter. 1 meter, 1 meter, 1 meter. Okay. So let's zoom in onto this RTA response a little bit. Okay, so there's the 4 traces of the different wattages. And I'm going to zoom in here as well. Let me smooth this magnitude just so we can see a bit of separation. Okay, so let's pick one point. frequency, and we'll cycle through. Okay, so it looks like they all have pretty much the same frequency response. So I'm just going to pick one. Let's pick here at 3.2. Okay. So currently we're looking at, if you look at the top right hand corner there, the 5 watts at 1 meter is 160, or is minus 65 decibels. Okay, let's go to the next one. That is 40 watts. Okay, I'm cycling a little bit different here. Okay, let's start with 40 watts. Okay, 40 watt is minus 57. 20 watt is minus 60. So that's around a 3 decibel drop. If I go to 10 watt, also close to another 3 decibel drop. And if I go to 5 watts, close to 3 decibel. So for each halving of the power, we get less 3 decibel in SPL output level difference. Okay, so that's interesting. So let's go to 1 wattage, which is the 5 watt, and look between the 3 different distances that we measured. Okay, so this is 5 watt at 2 meters. Let's just see. Okay, so let's start at half a meter is minus 58. At 1 meter, minus 62. Okay, so we double the distance, and that's almost a 58.4 to minus 62. So that's a 4 decibel. It's interesting. If we double again, it's another 4 decibels of drop, 4.5. If this wasn't a free field environment outdoor, it would probably be closer to a 6 decibel. I'm assuming here, correct me if I'm wrong. I'm assuming there's a lot of reflections in my hard surfaced garage that's adding to the signal. But if inverse square law is accurate, then for every doubling of the distance, we should have minus 6 decibels in pressure drop. Okay. So different settings on the tap would give us a 3 decibel variance, and different distances, doubling the distance, would give us sorry, lost my train of thought. Doubling the distance would give us minus 6 or 6 decibels of difference. If you're going closer by half the distance, then you would gain 6 decibels. If you're going double the distance, you would lose 6 decibels. Okay, so let's compare the different tappings to each other. Okay, so currently in the magnitude response, I've got nothing selected. So let's look at the other tappings compared to the loudest 5 watt tap. Okay, so that's at half a meter. If I go, let's see, 1 meter 10 watt tap, that's pretty close. Half a meter, that's louder, and that's a lot softer. So if you wanted to match seating speakers that are at different heights, so let's say the one seating speaker is lower by half a meter than the other one, you could use the tapping to adjust that output level between the two. Let's have a look at 1 meter 5 watt versus half a meter, no, this is 1 meter 10 watt. Well, let's go 2 meters. Okay, so if there's a meter difference between the two, you could also use the different tappings to get that level difference at the listener without having to go do zoning and adjusting volume. You could just use the tappings to compensate for the height differences in the ceiling. Okay, I will put up all this information, the transfer traces and the RTA response traces, on my website as a download link. Quite interesting to see how you can use, let's say, a 40 meter or 40 watts 2 meter compared to a 10 watt or 20 watt 1 meter, they are very close. So if there's a 1 meter difference between two areas, then you could just put one speaker that's a little bit higher at 40 watts and the other one that's closer to the listener by 1 meter, considering that that distance also needs to be a meter because it's doubling the distance. You can get that level control. But don't trust my word for it. Go measure it. This is a very useful application for installing loudspeakers where you might have 20 loudspeakers on one amplification line, and it's impossible to do volume adjustments for different zoning, but you can using the different tapping on the loudspeaker. Great. Thanks for watching. See you next time.